Hi everyone, welcome to this tutorial on R. Let's see what is R programming and how it helps. So R is well known as a language of data science. Now, if you really look at the ranking from survey of data mining experts based on the softwares they have often used in their work, R is used more than Python when it comes to data science. Python is also used, however, R is predominantly more used for data science kind of activities. It's a open source programming language used for statistical computing. It is one of the most popular programming languages today. It was inspired by S+, and it is similar to S programming language. So when it comes to data science, what we can say is R is a popularly used programming language across the globe. It is free and open source, as I mentioned. It is optimized for vector operations, which we will learn about later. It has an amazing community, has in fact 9,000 plus contributed or community packages, allowing us to do almost anything or everything using R. Now, when we talk about features of R, as I said, it's open source programming language. So you can install R for free and you can straight away start working. You wouldn't have to really go for a licensed version or pay for the software. Non-coders can also understand and perform programming in R as it is easy to understand, and it has various data structures and operators. It can be integrated with other programming languages like C, C++, Java, and Python. It consists of various inbuilt packages, a lot of sample data sets which can be used, and that makes reporting the results of an analysis easier by using R. Now, before we start learning about variables, loops, how you work with R, and so on, it would be good to know how you can set up R and work on R. So for that, what you can do is you can just go to r-project.org, and once we get to the home page of R project for statistical computing using this link, we can click on download R here. Now that brings you to a page to download it. Now there are various links here. So it shows you the comprehensive R archive network, that is CRAN mirrors, and it is available at different URLs. However, I would choose the first one, which is Zero Cloud. You can just click on this one, and then based on your operating system, whether you are working on a Linux machine, on a MacBook, or Windows, you can install it. So you can just click on this one. As of now, I'm using a Windows machine, so I can click on download R for Windows, and that takes me to this link which says binaries for base distribution. Now this is what we can use to work with R straight away. However, there is one more package, that is RStudio. We will see how we can set up that. Now this one takes us to the best mirror possible for our location from where we can download R. So you can click on this base and then you can download by clicking on this link. I have already downloaded this. So once you click on this one, you can just save it. So I have it here already in my downloads, and that's more than enough. Then you can just double click and you can go through the instructions to set up R. That would also allow you to basically set up a desktop shortcut, which I have already done here on my machine. And if I go in here, I see R base. You can click on this one, and that brings you to the page which you can use to straight away start working with R. Now, yes, there is one more package called RStudio, which is set up on top of base R, which makes working with R easier. Now, here also you can start working. So it shows you R console, and you can click on file. And if you have some scripts or files already written in the format of R, you can use those. So I can click on open script, and that takes me to a page where I have some files which are already existing. I can just select this one and click on open, and that shows me some options here. So I have an editor which shows me, say, if I want to get a library to use built-in data sets, I could summarize the data, I could do a cleanup, and we'll see all of this. But I would suggest using RStudio rather than just using base R. However, installing base R would be required. And depending on your machine configuration, like mine is a 64-bit, I have chosen 64-bit while I was setting up base R. Now, when it comes to RStudio, it is basically a package which makes working with R easier. So to install RStudio, what you can do is you can go to the RStudio homepage, or you can just go to Google and say type RStudio download, and then it takes you to this page. You can click on this which says download RStudio. You can choose your version. You can go for the free version, that is RStudio desktop, and you can click on this download, and then you can download RStudio for Windows, which I have already done, and then you have to run through the steps. So just click on this one, and I already have RStudio here, right? Now I can just basically use that. So for example, if I go to downloads and if I look for RStudio, if I do a double click, I can say yes, and then it takes me to the RStudio setup. Just click on next, and here you can choose the location. If you would want to place it in a specific location, click on next, and then it says select the start menu folder. So let RStudio be chosen here, click on install, and then it will basically start installing this in a particular location. Now in my case, it is already existing, right? So we can even click on show details and see what it is doing, what packages or what executables it is extracting. Now once this is done, then you will be able to use RStudio. You can also add a shortcut to your taskbar and you can continue using it. So I've already done this. This might take a couple of seconds. Just wait for this to complete and you would have RStudio, which is an easier way of working with R. So a lot of developers across the globe would be using RStudio when they are working with R to work on their data science or programming requirements. Now let's just wait. It is almost done. And now I can click on finish. So that part is done. You can add it as a shortcut. So RStudio has consistent commands. It has unified interface. It makes easy to navigate and manage through R. And it is set up on top of your R base. Now, if I click and open on this, so that's my RStudio, which is coming up. Now, here you see console, which will show you the result where you can give your commands. So where we can get text output. Now, again, I can choose a file. So I can just say open file, and then I can go into a particular location where I have downloaded some data. And then basically I can choose, say for example, RStudio, and that brings me here. So now you have your script which has some commands, right? On the left bottom you have console where you can see the output. On the right side you also have environment. Now that is to use or provide variables, and then we can also have plots which we can see here. Now we can look at this as an example. So here I am loading the built-in data sets. So what I can just do is I can place my cursor here and I can just do a control enter, and that basically loads the built-in data sets, which we can see here that has been done. Now there is an inbuilt iris data set, and we can just use head option to look at the first 6 lines of iris data set. So just place your cursor and do a control enter, and that shows you a summary, basically the first 6 lines of this data set, what it contains. We will look into this data set later. This is a default data set which you can easily find when you're working with R. You can also have your cursor placed on summary and then just do a control enter. So that basically shows you summary statistics for iris data. You can do a plot, and that basically shows you the plot, which you can also maximize and look at it in full screen. You can just do a zoom if you are interested in looking into this, and we will discuss how or what kind of information we can infer from the plots. Now, when it comes to cleaning up, you can just do detach, and then we can say package data sets. And here we had loaded those data sets. So we are just doing a detach, and we can say unload equals true. So I'll just do a control enter. I can also clear off the plots by doing this for whatever plots we had, and we can either do a edit and then we can do a clear console from here, or the shortcut is control R and you can clear off the console. So that's a simple way of starting your working with R by installing R Studio. So let's continue learning about working with R. And basically the first thing which we should learn here is about variables in R. So variables, as in any programming language, is a way to store your data value, factor of list values, or a data set or object in R. It allows us to conveniently reference the variable name, basically saving us from rewriting the data value or object many times in our program. So when we talk about variables in R, they are mainly used to store data with named locations that your programs can manipulate. A variable can be a combination of letters, digits, period, and underscore. So you can have some valid variables as total, sum. You can also have dot notation. So there are different naming or style conventions in R, and we can use dot to separate names in description of a variable. We can also start a variable with dot. We can include numbers in a variable. And remember, R is case sensitive. So we have to, whenever we declare a variable, we need to remember what case was used, as in the name of the variable. And there can be other conventions also, such as using an underscore or even using a case in between the variables. So variables can only consist of letters, numbers, periods, underscores, your dot followed by a letter, not a number. And we can declare our variables. We can also look at the type of the variables and the class to which it belongs. So there are some invalid variables which we are seeing here, so that also needs to be remembered. So this is an example where you can use an assignment operator, which you see here between x and 10, to assign a value to a variable. You could also do that by doing a dot y and then assign a value. You could be doing that by using a z and then having a computation done between x and y, and finally you could do a print. So let's see some example here before we move further, and for that I can bring up my RStudio here. So as I said, we can basically have different kind of variables or naming conventions. For example, I could do something like model 1, and then I can basically assign this. So this is just a variable, and I could be assigning anything to it. I could be assigning different data types which are available here. For example, I could do something like this, and I could do a control enter. So that's my variable. I can always do a type of, and then basically I can check what is the type of my variable. So it tells it's a character. I can also do a class, and then I can basically say show me the class, and that shows me it belongs to the character class. We'll learn about data types later, but we are using an assignment operator now. If I say what is model 1, it shows me the value, but if I would do something like this, then it says object model not found. And why? Because it is case sensitive. The variable which we had created was all in lowercase, and the one which we tried to call was starting with an uppercase. So you could have variables created in such way. I could also do something like hello underscore string, and this could be my variable where we are using an underscore, and then we can just give in something here, and that becomes my variable, which you can always call and check what is the value of that. You could also be doing something like this. So you could be using different cases, and then I could say something like this, and that's also my variable. And then I can basically look at the value of this variable. Now, if we try to create a variable where we start the variable name with a number, what would happen? So if I say something like this, and then if I try to assign a value to it, for example, let's say 100. Now this one will throw an error message because you cannot have your variable starting with a number. But if I used period and then basically give something like this, and let's try doing this by giving it a number. So if you see here, since we gave a period, the rule is that it should be followed always by a letter and not a number. So I could just remove this and that works perfectly fine. So these are some naming conventions which when you practice you will learn about. So now I can assign a variable by just doing a dot pairs and then assign any value to it. But always remember, if you are using a period, if you are using a notation, then in that case that should always be followed by a letter. One more thing which is always practiced in a real-time environment is that we cannot have spaces when we are creating variables. So for example, if I say first num and then I try to assign this a value, it basically fails. But obviously I could have done this by doing a underscore, and that perfectly works fine. And you can basically then call the value for this one. Always remember, one more standard practice which is followed in real-time environment is you will try to have variable names with a little meaning to them. So for example, if I would create a variable and I would say, for example, let's say bird, that's my variable name. And then if I assign this a value tiger, it works fine, but then it really does not make sense. And that would basically create a lot of ambiguity in our coding. So it is always good to say, for example, animal, and then I would say, okay, so tiger is an animal, and that basically not only allows me to assign a value to the variable, but it is also a little bit more meaningful. Now, when we talk about variables, it is also good to know the different data types which are available in R. Now, like any other programming language, R also supports different data types. So you have your logical data types such as true and false. You have numeric values, which is say these numbers. You could also be creating an integer, which is 3L and 40L, 4L, and so on. You can have a complex number. You can have characters, which can be just letters or a set of letters or anything which is within the quotes, or you can even have raw data. So these are different data types. We can again see quick examples here on data types. Let me come out of this one. And as we saw already, when we created model 1, this was character. Now I can just say X and let's say 100, and obviously this is going to be not my integer. Okay, so let's see this. What is this one? This one by default is double. It is by default double. So if I would want an integer, then I would say, for example, something like this. And this one you can check by using type of, and you can see the value for this one. So this is an integer. So similarly, you can have character, you can have complex, you can have raw data, you can have numeric values. So all these are different data types. You could also be saying, for example, I would want to check the Boolean. So I could check this and select this one. And now when I check the value for A, it is true. And we will learn about logical operators, where we can basically be using these values assigned to the variables to compare, to compute between different variables. So this is a simple small example of using variables. So we have seen here using variables and also using the assignment operator, and then assigning values to the variables and different naming conventions. We can also be using different data types which R supports, and work with the variables. Now, once we have learned about variables or data types, let's also just first learn about your operators and how they can be used in your R programming language. Now, we might be intending to do some calculations on numeric values, find out differences between values, or say, for example, compare values. So in that, we can be using different kind of operators. So we have various operators. We have arithmetic operators, we have rational operators, we also have logical operators. So before we straight away look into logical operators, let's also understand about the basics, such as your arithmetic operators, which supports, for example, let me pull up a notepad file here. And when we talk about arithmetic operators here, we are talking about your addition, you have subtraction, you have multiplication, you have division, and you have remainder or modulus, and you have exponent. And what makes it also important is that when you're using arithmetic operators, you also need to know about the order of operations. So when you say order of operations, always the priority is to parenthesis. So that takes the priority. You have then exponent or your computation if that would involve exponent. So let's say exponent here, which is then followed by your multiplication and division. And that one also follows an order of left to right, whichever comes first when we talk about multiplication and division. And similarly, when we talk about addition and subtraction, it is left to right, whichever comes first. So these are some of the arithmetic operators. Now we can see some examples here quickly, although these are some simple examples. So for example, I can say 100 plus 100, and that gives me the value, right? You can always do 100 minus 50. You can do 100 multiplication. You could do 100 division 2, or you could also use modulus 2, which basically gives you an error here. So I will, oh, just give me a minute. So let's give here one more percentage sign. And that basically says what would be the remainder. So if we would want to look at the ordering when we are using this arithmetic operators, we can see an example. So for example, if I say 34 plus 46 divided by 2 gives me 57. However, if I use 34 plus 46 in parentheses, which gets the priority, and then I divide, my result is different. So understanding what arithmetic operators you can use, and also the ordering in which that leads to the computation, is very important. So we can use all of these arithmetic operators, and to control the ordering, we can be using parentheses, or we can have our computations ordered with what kind of operation we would want, whether that would be multiplication or division, addition, or subtraction. Now at any point of time, I can always do a control L, and that allows me to clear my console. Let's continue our learning and let's learn about operators. So when we speak about arithmetic operators, we see that allows us to do computations, but we have also rational and logical operators which help us in doing our computations or comparing values or sometimes finding difference between different values, whether those are group of values or whether those are individual values. So with your rational and logical operators, you can compare data values. So if we would want to see if the values match or not match, or if the values are above or below, equal to something, and so on. So when we talk about your rational operators, we basically have, in case of rational or logical operators, so we obviously have greater than, you have less than, you have greater than or equal, you have less than or equal, you have equal to, and you have not equal. These are some of your rational operators, we can say. And when you talk about your logical operators, then you have and, you have or, and you have not. So and is when it compares two values. So it returns true if both the conditions are true, else it will return a false. So for example, if I have 10 greater than 20 and 10 is less than 20, now that's not possible. And we are comparing the result of both of these. So we are checking if both the conditions are true, and that's not really true here. So we see the value as false. Now, if I would have replaced this and with or, it would check even if one of the conditions is true, it would basically show me a result as true. You can also use a not operator, which takes each element of the vector and gives the opposite value. So we can be using any one of these operators and then basically do our computations. So let's see some examples about these logical operators. Now either you could just be assigning values to your variables and check, or you could also be picking up a data set from your machine and then try to use these logical operators. So for example, if I say X has been assigned 100, Y has been assigned 200, and if I try to say X equals Y, so that already checks the value and compares and tells me that's not true, it is false. And if I would have used a not operator, for example, if I would have said something like this one, so it tells me true. So I can just check simple conditions like this. I can say, is my Y greater than X? And that tells me yes, it is true. If I say Y is greater than or equal to X, well, it would still say true, because when you are saying greater than or equal to X, so when you're saying this one, it works fine, right? Now we can also be picking up some data set, and for that what I can do is I can pick up one of the data set from my machine. So I can go in here and I have some data sets. Let's look into that. And I would be interested in taking this auction data set and loading the values here. So I'll get this path and I will come here. I can use auction as my variable name. You could have given a dot separated name. For example, I could have said auction dot data if this is what you want to do, and then you can assign variable a value. So here I'll say read.csv, and I intend to pick up a file, so I give this path. And when we are working on Windows machine, we need to give a double slash So I'll say auction.csv. Now I could give other things like header being true, what is the separator. If you would want to fill values to take care of missing values, we can look at all of those. So here I'll just add a backslash. I will add a backslash, and I will basically just do a control enter. Now I can look at the values of this by just doing a auction.data, and I can see what values it has. So it has a lot of data here. It has a lot of your data here. You could have used some other functions which we can see later, where I can choose head and I can see the first top 5 values. So we can basically assign data to the variable and continue working on this. Now we can keep it simple. So let me repeat this step, and here I will say auction as my variable name, and I'll assign this. So I can basically do also a view on auction. So auction, and then basically that shows me a tabular format of the data, which allows me to look into the data and basically understand it, and then I can, you know, use this to work on variables. So what I can do here is I can say X, and let's say assign some value to this, for which I would want to work on my data set, which is auction. Now what do I want to do here? So let's use auction, and then I can use a dollar symbol, and I can choose which column I'm interested in. So for example, let's choose bidder, and I can just give a value to this one, and let's pick up a name. So let's say tweak, and that's the name. And I can be assigning all the values to this, or I could say I would want to use another condition. So I'll say auction dollar, and then let's take this value of bid, and let's say it is equals to 100, and then I ended up with comma, and I can try doing this. Now here it gives me a problem, because what we did was we did not use the right operator. So we will say, for example, and. So I will say X is being assigned the value of auction bidder being tweak, and auction bid value being 100. So now once we do this, I can look at the value of X, and that shows me the value. So this is just a simple example of using a logical operator. Now I could have just said, instead of and, I could have used or, which is basically a pipe which you have to use, and that gives you or condition. And now hit on enter, and if I now look at the values of X, it will show me a lot of values, because we have given an or condition which basically matches one of the conditions. So in this way we can use logical operators and continue working and continue doing our computations. Let's learn about print formatting and how print can be used to view your data. When you talk about R, R uses print function to display the variables. So for example, if I have assigned number 10 to X, I can do a print X, and that will show me the value of X. What we see here with 1 in square brackets, that also has a meaning, which basically means it is a vector, and we'll learn about vectors later. So R uses the paste and paste zero functions to format strings and variables together for printing in few different ways. For example, if I would do this, which I say is print paste, and then pass in two strings here or two words here, such as hello and world, that would be printed as follows. Now I could also do a print paste and then use a separator. So my print would look something like this. If I use paste 0, then that avoids any space between these two words, or for example, these three words. So let's see some basic examples here when we talk about print. So for example, if I bring up my RStudio, here is an example. So X, as we say, now this is your assignment operator, which we already discussed. Now I can be assigning a value to this. So I can just place my cursor here and I can just hit on Control Enter. So value has been assigned. Now let's look at the value of X. Now I could also be doing a print X explicitly by using print function. For example, if I do similarly for message as hello, and then I can print the message by using print. Now, if for example, I do something like this is not going to print anything until I call the variable or I use a print function. So for example, if I do a Y, we see auto printing shows us the value, or I could do explicitly by using the print function by explicit printing. Now whenever we look at this number 1, as I mentioned, it means Y is a vector and 5 is its first element. Now you can also use operator to create integer sequences, and we'll learn about sequences or list later, but this is just a simple example. So I am creating an integer sequence of length 20. I can place my cursor here, which would start with 10 and end at 30. So let's look at this values for our sequence of integers. Now at any point of time, you can always use a class to look at the class of say X, and that shows me the classes of integers. Now looking further, when we talk about different data types, as we learned few minutes before, so R has basically 5 basic or atomic classes of objects. So you have character, numeric values, that is real numbers, you have integers, you have complex, and you have logical values. Let's spend some time in understanding some basic arithmetic operations and how you can do it using your R programming language. Now here I've opened up RStudio, and these are some basic examples such as performing arithmetic operations. Now for example, we can add two numbers, and I can just place my cursor here and press Control Enter. That shows me the addition. I can do a subtraction, I can do multiplication, division, also going for exponential power, or use modulo, which returns the remainder. Now, when we are performing operations, what we can also do is we can change the order of operations. And in this case, we are using parentheses. So I am putting in 500 into 2 in a parenthesis plus 80 divided by 2. So first it operates what is given in parenthesis, and that's why I get a result 1040. Similarly, I can change the order of operations. So here I can give 500 into and then something in the parenthesis, so that gets operated first, and hence you get result of 1500. Now we have already discussed about the assignment operator, and what we can do here is we can assign variables some value. So for example, I create a variable called selling, and then I would assign it a value. Similarly for cost, and then we can do some calculation. So we can say profit is selling minus cost. We can do that, and here I can look at the value of profit, which shows me 250. Now let's also spend some time in understanding data types in R. So we can have different types of data. So this one shows me an example of assigning a decimal value, which is part of a numeric class. So I can do this, and then if I would be interested in seeing the value of num, so I can just look at the value of num. If I would be interested in looking at the type of num, so I can do that here by just typing in type of, and then select this one and pass in your num, and it shows me the value is double. I can also look at what class it belongs to, and that shows me it is numeric. So in this way, you can not only assign values to a variable, but you can look at the class and type of it. Now here we can assign whole numbers, which are also known as integers. Now if I look at the type of this, it shows me double. So if I would want to explicitly assign an integer, I could have done, for example, let's say j, and I could have used the assignment operator, and I could have done this. And then if I look at the value of j, it shows me the value. But what we would be interested in looking at the class of j, so we can do this and it shows me it is an integer. So explicitly, either I can assign this by using a capital L, or I could use a function called as.integer. So we'll see that later. Now we can also assign Boolean values, or basically your logicals. So here we assign true and then we do a false, and we can look at the type of T, and that tells me it is a logical class. Now similarly, you might be interested in working on text or string values, and here we can do this by saying ch and then passing in a value. Look at the class of this, it tells me it is, the data type is character, and if you look at the type of it, it says me character. Similarly, R also supports complex data types, so we can do that too by just doing this and look at the class of it. It tells me it is complex, and you can also pull out the length of this by, now here we are doing a length on the character. So let's look at this one, and it shows me what is the length of this. Now, one of the useful functions which we usually use in R is print. Now I can simply do a print hey, and that prints whatever value is passed to print. I can assign a value to a variable and then print it. So that is also fine. You could have also, without using function, just typed y, and that also shows the value. However, sometimes using print as an explicit function can be useful. It makes your code more readable. Now here we would use an inbuilt data set, that is empty cars, and then if you would want to print the data set, that shows me the values, which shows me the car models and different other features such as mileage, cylinder, horsepower, and so on. Now one of the use case of print with a paste function can also be seen here. So I'm doing a print paste, and that basically prints whatever was passed in a concatenated way. I could also do a print paste with a separator if I would want to format my data in a particular way. So here I've used separator as comma. There is one more function, paste 0, which can be used. So I'm doing here paste 0, and that tells me just concatenate these values without any space. So paste 0 shows no space between these two elements which were passed. Now we can explicitly do some printing, and for that I'm using a sprintf option. I am going to pass in %s, which is for string, and %f for float, and we can print the values of this. So these are some basic operations or usage of your functions to basically do some computations or look at your results. So when you talk about basic type of any R object, it is a vector. And when we talk about vectors, empty vectors can be created with vector function. A vector can contain objects of same type or a class. Now when we talk about list is a vector which contains objects of different classes. So these are some basic examples. So apart from your print formatting, we can be looking at what we call as R objects, such as vectors or lists and so on. So when we talk about vectors, it is a sequence of data elements of same basic type. We use the function to declare a vector. So we can always do a C function to declare a vector. For example, here we are creating a variable v1 and we are assigning it a vector by using C and then giving some basic types, so numbers 1 to 5, or for example words. You can always do a print, or you can also use a class to find out what is the class of the elements or the values which have been passed to the particular object. So we can look at some examples like this. For example, we can see here, so list is a vector which contains objects of different classes. So you can have numeric objects, so that is your numbers such as 1, 2, etc., which are your numeric values. For example, here what we are doing is we are assigning a value 1 to A, and that can then be used. I can either do a print or I can just use auto printing. I can also do here a value for AI, or I could be doing something like this, which shows me 0, which can be for missing value. So if I would want to use auto printing, I can just call A and it shows me the value what has been assigned to it. You can always use a type of to look at the value of A, which is double by default. And if I look at type of AI, that is basically an integer because we used L here. So in this way, we can continue working with, say, different classes of objects. So for example, let's create a vector here. So I can say v1 and then basically assign it by using a C function and then pass in the values to this one, and that basically gives me a variable, and you can look at what are the values assigned to it. Now if I look at the class of v1, that shows me it is numeric. If you use type of, and then you would want to see the values of v1, that shows me the values are double. Now as we were seeing here, we can be looking at the class. So for example, if I create one more variable and then assign values to it using C, so passing in some words here. For example, let's go and say hello world, and then I can basically do this and look at the values of this one. I could also explicitly print, as we discussed earlier, by doing a print v2. We could also be having a paste function if we would want to use that. So for example, if I would do a paste function, I could be using, and this is missing a bracket, so let's complete this, and that shows me the value. I could have also used, for example, paste 0 function, and that also works fine. So it depends on what we are looking at here. So if I look at class of v1 which we had, it is numeric, and v2 is basically having elements which are of the class character. So this is just a simple example of having your print functions, having vectors created, printing out the values of those, printing out class and type of these. To continue our learning on vectors, as I mentioned earlier, we can use the C function, which can be used to create vectors of objects by concatenating things together. So for example, if we look at this one which says X, and then I use C function and I say 0.5 and 0.6, so we can have a vector of numeric types. So let's do this, and then we can look at the value of X. So it shows me my vector which has 0.5 and 0.06. I can also have my vector of logical values, and now let's look at the value of X. So it has true and false, or we could have done it in this way where we can then look at the values. So we can use the short form by using capital T and F. I can create a vector with character types and then look at the values of those. I can also be creating a sequence of integers as we saw in previous example, and then look at the values which start at 9 and end at 29. Now you can also create with complex types and look at the values. So these are some simple examples of creating vectors. Now we can also use vector function to initialize vectors. So for example, if I would do this, where I'm saying my vector will be of type numeric, length is 10, and then look at the values. So it just shows me a vector which has all zeros and the length is 10. Now you can create a vector of numbers by doing this, as we saw in previous example, and use explicit printing to look at the values, or might be a letters, and then use a print statement to print function to basically look at the values of the vector. Now we can also try concatenating the above two, so that creates a mixed vector which has two different kind of types here. So I can do a mixed vector by using the C function and then passing in my numbers, which has numeric types, and letters, which has character types. And then we can basically do a printing of this, which shows me the value. But here what we see is coercion. That is basically casting, if you would know as the word in different programming languages. So it basically coerces the numbers to character, as characters cannot be coerced into numbers. And then you can print the values of this mixed vector where everything is of character types. So for example, at this point of time, if I would have done something like class of mixed vector, and if I would want to look into the values of this one, it shows me everything is of character types here. Now data type of different vectors can be returned by the function class, as we saw just now. So it is common to use the class function to integrate an object asking what is the class. Now we can create one-dimensional objects such as an integer vector, which we have done earlier, and then look at the class of it, which tells me it is an integer. I can also create a numeric vector by giving in some values here. So when we do this, so I have given the vector function C and then giving in the value and look at the class, it shows me it would have numeric values. Now you can create a character vector and then basically look at the values of it. Now at any point of time in all of these, for example, if I would do num, I can see what are the values assigned to it. I can do letters, and I can see the values of this. So let me just create some space here. Now I can create a factor vector and then look at the values of it, or also you can see what is the value in this factor vector. So here we said as dot factor, so factor function is being used here, and we are creating a vector of letters, and then we look at the class. We also look at the values what are assigned to this or what are in this particular vector. So if you look into all of these vector examples, initially we were using an assignment operator where we were using the C function, and when we started creating vectors by say concatenating or vectors of particular types, we are using equals here, and that also is fine. Now looking further, when we look at concatenating two different kind of vectors, so for example here we have say numbers and letters, as we discussed earlier, it will do coercion, that is change one type into other. Now when we talk about one-dimensional objects, we can have integer vectors or say float, which we saw just now, ending at 10.5. So when we say C 1 is to 10, it basically starts with 1, but then there is also, you can say, a coercion happening here, and then you have the values ending at 10.5, that is float, and I can look at the class of it. And when we did a class of Did we do a class? Yeah. So let's come here and let's do a class of this one. It says me it is numeric. You can look at the values of it. Similarly, you can create a character vector which is 1 to 10 and then basically look at the class of it, or basically the value of this vector, or as we did the factor vector. Now for two dimensionals, we will explore that when we are learning about matrix. So as of now, let's forget that. Now when you talk about mixing objects, there are occasions when classes of R objects get mixed together. So that could be accidentally or that could be intentional. So if you look at this example here, we have Y, which has been given values which is 1.7 and A. And at this stage, if I would look at the value of Y, that's my vector. If you look at the class of Y, that shows me it is as character. Now when you look at some other examples, so let's pass in logical and numeric values. What would happen in this case? So we can again use class of Y, and that basically has numeric. And if you would want to look at the value of Y, that shows me 1 and 2 here. Let's go further. So let's look at the value of this one. So Y, and then basically see what is the value of Y. So it is A, true. And you can also look at the class of it. Now we are mixing objects of two different classes in a vector. Remember, when we talk about vector, we always talk about vector having elements of same type. But when we talk about lists, which we will learn later, that would have basically, or that can have your each element of different type. So for vectors, it is not allowed. So when different objects are mixed in a vector, coercion occurs so that every element in the vector is of the same class. Now, we have seen earlier the implicit coercion, where R tries to find a way to represent all the objects or elements, as I say, so all the objects in the vector in a reasonable fashion. So we can also be doing explicit coercion, so that is from one class to another by using a as dot and then using a relevant function. So if I have X here, now if I look at the class of X, it tells me it is an integer, but I can convert that to numeric by doing a as dot numeric or as dot logical or as dot character to basically do a coercion and change the class of the objects. Now, if R cannot figure out how to coerce an object, this will result in NAs being produced, which we can also relate to missing values or not applicable values. So for example, if we create X and look at the class of X, it tells me it is character. Let's try changing character to numeric, which will not work. And it says NAs are introduced. If you do it even in logical, that would not work, and it shows me NA values, or if you do a complex, it says values have been introduced. So at this point of time, if I look at the value of X, it tells me it was assigned ABC, and we try to convert that into a different class. Now, when we talk about vectors, it is also good to know about attributes in brief. So all your R objects have attributes, that is metadata for object. So when you talk about R object attributes, you could have names, you can have dimension names, you can have the dimensions, that is matrices and arrays. You can look at the classes such as integer, numeric, and so on. And you can also look at length, which is user defined attribute. So if I say X, we are assigning a value to X. Now at this point of time, if I see my value to X is 1, but then all objects need not necessarily have attributes. So in that case, whenever you try to use an attributes function, that would return null. So at this point of time, if I look at the attributes of X, it shows me null value. So these are some of the basics which help us in working with R and using your vector function, or looking at the coercion which is implicitly happening or explicitly can be done by us by using a as dot sum function. Now let's learn about lists and how we can work using R on list. When we talk about vector, which we saw in previous examples, vector is a one-dimensional array, right? And it can hold elements only of same type. So we would say vector is more of one-dimensional. But when you talk about list is a generic vector that can contain objects of different types. So when you talk about, say for example, matrices can also hold elements of same type, but in matrices it is a two-dimensional array. We will talk about matrices also, we will learn. So when you talk about lists, they can contain all kind of R objects. So you can have dates, you can have data frames, you can have vectors, and many more. So in list, there is no coercion which is required, that is changing of data type. There is no loss of functionality, and lists do not follow any predefined structure. Now we can create lists using this list function as it is shown here. So you can create a variable and then assign a list to it, where you can be using either passing in a vector, or what you can do is you can simply create a list by using this list function. So let's see some example here. Now for that, what we can do is I can bring up my R Studio, where we can see an example on list and how it works. So when you talk about list, what you can do here is, let me close this one and this one. Yeah. So what we can do is we can basically say, for example, test, and I can basically give something here. So for example, I can say music tracks, and then I can say how many hundred of them, and I can say, let's give 100 as number, and then we can say how many of them got 5 stars, and I can do this. So I can check this, and this shows me all the objects or elements of this list, right? Now when we do this, what we are doing is we are creating a vector, right? And vector basically can have coercion depending on what are the elements which are passed, because whenever you use the C and you create a vector, it will only accept elements of the same type. So for example, if I do a class on test, it shows me here all the objects are of type character, right? And you can also use type of to check for our test variable, and it is basically having all the objects as character. Now how would you create a list? So what we can do is we can use a list function. So for example, let's again do a test here, but this time I'm interested in creating a list, and list can have objects of different types. So let's say music tracks, and then I can just give 100, and I can say with rating 5. And now if I look at my test, it shows me all the elements of your particular list. Here we see each element or each object with a double bracket, and we can see each element. Now what we can also do is we can use is list function, and then we can pass in test here to check what is it, and it is a list, right? So here we have created a list, but if for example we take the previous example where we were creating a vector, and if I would do a is list, it would show me false, right? So we just created a simple list, and we can also arrange labels, or we can use a name function to basically give names. So what I can do here is, let me create a list first. So I can do that like this. And now what I can do is I can do a name, and I can use a name function to this test. And then basically what I can do is I can pass labels. So here I can just give in some names here. So for example, I can say, let's give it a name, product. So say we are talking about product of a company, and then we can say here I can give count, and here I can give rating, and this is basically to give in names. So let's just give, there's some error here, let me just check this. So let's use this name function here, and what I'll do is I will basically use names. And now let's do a test. So that shows me the names what we have assigned to our list objects. Now we can always access the elements of or objects from a list using indices or even using double square. So for example, I have test here, and basically I can give something like this, which gives me based on the indices the position where you are accessing the elements of the list. So we can do this. What I can also do is we can specify names when creating a particular list. So for example, what I can also do is I can say product dot category, and now I can just give list function. So I would want to assign names while creating a list. So I can say, for example, product, and this would be, say, music tracks. Then I can give, say, for example, count, and count would be 100, and then ratings, and I can say 5, and now we can basically access this list which we have created. So what we have done here, unlike earlier when we created a list and then basically used names function to assign a name to it or each object, here while creating a list itself we passed in the names. So we can also do that. Now if you would want to basically display the list or compactly display structure of a list, we can always use the string function, and here I can pass in the name. So let's choose this one, and this is in a more compact way listing down the elements of your list. So list can be containing other lists also, and we can also do that. So for example, I create one more list. For example, I can say similar product, and here I can give a list again, and what I would want to do is I would want to say product equals, and I can say film, and then I can basically give a count, and then I can give ratings, say 4. And here what I've done is I have just created one more list, but my intention is not just to create a list, but I would want to add this to our existing list. So what we can do here is we can take our previous list, that is product.category, like what we did earlier, and now I intend to say list, and here I would want to say, for example, let's copy this, or we can just, so this is what we were doing when we were creating a list using product, giving the names while creating a list. And what I also want to do is here I will just say similar and then pass in similar dot prod. So now if you look at our list, we have just added new elements. So this is one more way where we can create a list and we can basically add, or our list can have other lists. So when we talk about subsetting or extending list, so one of the main ways, as I said, to access a specific element or a subset, we use double brackets, and we can always do that. So for example, we take our prod dot category, and then I would want to access a particular element. So I can always do this by giving the index positions, and I can access the elements of my list. So this is one single way. Now here, if we use a single bracket instead of double bracket, then in that case, the output would be a list. So if I look at this one, then this would be a list. But if you use double brackets, then you're accessing a particular object. If we were creating a vector, we could just be using a subset by using the C function. Now, what we can also do is we can subset by names or even logicals. So what we can do here is we can take this product category, and if we have defined names, then in that case, what I can do is I can say I would be interested in music tracks, and this is the name we had given. So we can close this one, and we can try accessing the elements here. So what's the name we had given? So no, it's not music tracks, that's the value. The name is product. So we do this, and then we can access the elements. What we can also do is we can be subsetting based on logicals. So what we can do is we can basically just give something like this, and here we can pass in values. Something like this. And we missed a bracket. So that's also a way of pulling out the values. So you can be doing a subsetting using the names which you have assigned to objects within your list, or you can say names which you have assigned to the elements, or by using logicals. Now what we can also do is we can use the dollar function. Now if you see here, we are looking at the name, and that is preceded by dollar. So we can always pull out the values from our list by giving the list name and then give a dollar symbol and then choose the name. For example, if I choose product, I can list the values here. I can be looking at, say, dollar and then choose a count. And this is also one way of accessing your elements from the list using your dollar symbol. Now, to add elements to a list, as I said, you can add a vector of names, and that can be passed to your list. So these are different ways in which you can work with list, and then you can access the elements either using indices or using names, or even using dollar symbol and pointing the right names. So this is one simple example of working with your list. Now one more, and now I can just do a Control L and I can clear that off. So your list, always remember, is a generic vector that can contain objects of different types. Now when we talk about matrices, now matrix is a collection of data elements arranged in two-dimensional rectangular layout. So we can use matrix function to create a matrix as shown here. So matrix is two-dimensional. Now we already know that vector is one-dimensional array of data elements. or a sequence of data elements. But when we talk about matrix, it's a collection of data elements that is two-dimensional, arranged in fixed number of rows and columns. So here you see that we are creating a matrix, and we have specified the number of rows is 3, number of columns is 3, and we want it to be arranged by row, where we have given the value as true. So always remember, matrix is two-dimensional, and matrix can have only one atomic vector type, unlike your list. It's a natural extension of vector going from one dimension to two dimensions. So matrix actually needs a vector which contains values that you place in a matrix, and at least one matrix dimension. So we can choose to specify the number of rows or number of columns when we are creating matrix. So let's see a quick example of working with matrix. So for example, I could just say matrix, which will have values 1 to 6, and then I can basically give n row, and you can give a value to this one, and that's my matrix. Similarly, you could also be giving n columns. So I can just say n col, and I can choose this one and then pass in the value. So that's a matrix where R fills values column by column. Now if you intend to fill up matrix in a row wise fashion, so that your values 1, 2 and 3 are in first row, then we have to just modify this in a little bit different way. So we have to say matrix 1 colon 6, n row is 2, and then I can give by row. So you always have these helper functions which allow you to pull out the values. So for example, I do this, and then I can do a control enter. So now if you see, you have the values 1, 2 and 3 in your first row. So when we pass a matrix function to a vector that is too short to fill up an entire matrix, then something different happens. We can have a look at this. So say you pass a vector containing value 1 to 3 to the matrix function, and say explicitly you want a matrix with 2 rows and 3 columns. How do we do that? So for example, I can say matrix, and here I can say 1 is to 3. Now I can give n row, and then I can give the number of rows which we want is 2, and then I say n column, and this one I'll say 3. So I can do this, and here what I have done is I have given the values 1 to 3. I have said number of rows is 2 and your number of columns is 3. So here R fills the matrix column by column and simply repeats the vector. Now, if you want to fill using a 4-element vector in a 6-element matrix, in that case, obviously, R will generate a warning message. Now, apart from the simple matrix function which we are seeing, you also have some functions such as rbind and cbind, which are offers when you are working with matrices. So we can use those. So for example, I could say cbind, I could say 1 colon 3, and then I can say 1 colon 3, and that's my cbind, that is column bind, where I'm passing the values 1 to 3 and which are stacked in columns. I can also do rbind, and similarly we can be passing in the values. So I can say rbind, and that basically arranges the values row wise. So be creating a variable, for example, let's say n, and let me create a matrix here. So I'll say matrix. Now that will contain 1 to 6, and I can say by row, and then you can give value which is true, and then I can basically say the number of rows is going to be 2, and this is also fine. So let's look at the value of n here. So you basically created a matrix with 1 to 6. You arrange them row wise, and the number of rows what you have chosen is 2. So what we can also do is we can use rbind and we can add values to it. So for example, if I want to add values 7 to 9, what I can simply do is I can do a R bind. I can say I would want to edit my n and then pass in the values. So I can just do this, and this has basically appended or added values to existing matrix. So similarly, you could have done a column bind and you could have added values to your existing matrix. So for example, if I take this one and look at my n, and what I could do is I could do a C bind, and then I can basically take my n and then pass in values to this one. So let's say 10 and 11, and basically I've added 10 and 11 as a column to my existing matrix. So this is one simple way where you work with a matrix and you are appending the values either at a row level or at a column level. So let's also look at some other examples. So basically, if you would want to work with matrix, one of the useful things would be naming the matrix. That is, in case of matrices, we can assign names to either the columns or the rows. If you don't do it, we see the default values here, which follows a numbering. But what we can also do is we can use two functions here. One is row names, or you can use column names. So these are the two functions which can be used. So for example, let's do a control L. Let's try to get our n, and this is what we are doing here. But what we would want to do is we would want to give them some names. So for example, I'll say row names, and then I will basically pass in a vector which has row names or vector which has column names. So what I can do here is I can say I would want to give row names to n, and then I basically give some value. So for example, let's say row 1, and then let's say row 2, and now I can look at my n, which has the row names assigned to my rows. Similarly, I could have also given column names. So all I need to do here is I need to say column 1, and then I will say column 2, and then I can be using column names. And let's look at this one. So what went wrong here? So we have 3 columns here. We forgot that. So we have to add one more column name, and then it should be fine. So now if you look at this one, we have just given row names and column names. So naming the columns or rows in your matrices can be very useful. Now, as the previous error says, there is also a function called dim names, and that's basically an argument of matrix function which can be used. So we could also do something like this. So for example, I have dim names. So let's have our n, and then what you can do is you can do a dim names, which you can then just create a list, and in this one you can pass in a vector for row 1 and then vector for row 2. And what we can do here is once we have given this, let's give a comma here and then give C, and then give your column names, which is column 1, column 2, and then basically column 3. And now if you just look at dim names, so you can just see that you have given some row names and column names, and this can be used basically to assign to your list. So if you try to store different objects in a matrix, what would happen? Coercion would take place, right? So for example, if I have X, and let's basically try to create a matrix which will have 1 to 8, and let's say the number of columns is going to be 2. So let's look at our X, and this has the values. Now what if I create, say, L, and then basically I will create a matrix which will be a matrix of letters. So let's say letters, and then here with letters I'll say 1:6. Now I would want to give the number of rows, and let's give it say 4, and let's say number of columns, and let's give it 3. And now let's look at the value of L. So it has letters and X is having numbers. And what if we bind them together using cbind, which is for column wise binding? So for example, if I do a cbind and then pass in my X comma L, so if you see here, there is a coercion which has happened where everything is converted into characters. So you can always do a class and you can check. So this is a simple example of working with matrices. There are much more. You can do subsetting like what we saw in list, but that we can learn later.